Hackrf is an open-source hardware project created by Michael Osman. The project initially got off the ground as a DARPA-funded initiative. It was then funded through Kickstarter and became a huge success. The best way to understand what a Hackrf does is to think of a sound card. A sound card lets software on your computer access the audio spectrum through a microphone and speaker. As you're watching this video, the sound card in your computer or some other device is accessing the audio spectrum so that you can hear what I'm saying. You can think of a Hackrf in the same way, but instead of accessing the audio spectrum through a microphone and speaker, it lets you access the radio spectrum with an antenna. This means you can use software to build radio systems and utilize the radio spectrum instead of working in hardware, whether it be pre-built hardware or something you put together yourself. Being able to build radio devices in software instead of hardware is of course very convenient and extremely flexible. You can do a lot of stuff with a Hackrf. Things like listening to conversations between spacecraft, such as the space station and Soyuz, as they communicate with their mission control staff on the ground. You can listen to pulsar stars and do other radio astronomy. Use two of them with synced clocks to create a passive radar system. Track aircraft and ships using their transponder data. Examine the signal from your car or garage door key fob and see if they're actually secure or not. Have fun with RFID and NFC technology. Play with GSM, CDMA, LTE, and other cell phone technologies. Receive telemetry data from model aircraft and drones, and even use it to control these kinds of devices. Get live images from weather satellites. Build your own GPS receiver and play with the GPS system. You can use it as a spectrum analyzer that covers about 1 MHz up to 6 GHz. You can even plug it into an Android phone or tablet and use it as a portable spectrum analyzer using some fantastic software from Dennis Mantz. You can also patch into the interface headers and use the DAC and ADC directly by passing the analog front of the board, and since this part of the board is full duplex, you can use it simultaneously as a signal generator and an oscilloscope to do things like impedance matching. While using it here in Hong Kong, we were able to hear some Chinese military chatter, a Chinese number station, shortwave radio broadcasts, taxi dispatch communications, wireless microphones from karaoke places, and a heap of other things. We were also able to receive some interesting text data and set up some restaurant paging systems. And in Macau, we saw a heap of strange data, which was probably from gaming machines. When using your device, remember that broadcasting on certain frequencies or at certain power levels can require a license or be illegal, depending on where you are. These rules are generally in place for a good reason, and it's important to be aware of local laws. If you have questions and can't find the answer by Googling, a good place to start is the reddit.com forums.